Hello dear students, welcome to Tejuma YouTube channel. In this video, I am going to give the list of formulae from the chapter electromagnetic waves. This is the 8th chapter from 2nd PUC physics syllabus. So starting with the topics, here I have divided the chapter into main topics. One is the electromagnetic waves and electromagnetic spectrum. So starting with the introduction part, since I'm intended to give the list of formulae in this video, I'm not going to give an explanation or introduction theoretical explanation at all. So you can just go through it. Let me start with the first formula. So here we have the Ampere circuital law. So the Ampere circuital law states that the line integral of magnetic field around a closed loop is equal to mu naught times current enclosed by the path. For example, if I consider there is a wire here through which the current I is flowing, there will be magnetic field around it like this. Okay, so at any particular point, let me consider the magnetic field here, okay, will be in this direction. So that is dB. Okay, so this is at a distance small r. The total magnetic field along this circumference, total length is L or 2 pi r you can take. So the total magnetic field around this wire is given by the mu naught times current enclosed by this path. So we can also write this like this: the line integral of magnetic field B dot dl in vector form is equal to mu naught times current enclosed. You can find out the total magnetic field, net magnetic field here. So let me solve this. You will get B into dl into cos 0. So what is dl here? Dl is the length element along this wire. So here you can consider the small length element here. That is also directed in the same direction. So you will get theta 0. Therefore, that is equal to mu naught times current enclosed. So B is a constant, which will come out at that particular distance. Integration of dl is equal to mu naught times I. So B into integration of dl is 2 pi r. 2 pi r is equal to mu naught times I. So B is equal to mu naught times I divided by 2 pi r will give you the expression for magnetic field. Okay, so this is the formula for magnetic field at a particular point due to infinite straight wire. So we can extend this wire till infinity. Okay, this is the one. This is called Ampere circuital law. Is it clear? So moving on to next one, we have displacement current formula. So Maxwell told that there is ambiguity in the Maxwell's what is it, Ampere's circuital law. So he has considered that Ampere's circuital law not only should have the conventional current or the current I, we need to consider one more current, that is called displacement current. So he has explained what is displacement current. So displacement current is the current produced due to varying electric field. So this definition is important. And he derives the expression for displacement current, that is given by id is equal to epsilon naught d phi by dt. You can understand why we need to consider the displacement current by going through the NCERT syllabus. So here I'm just giving you the formula. So here the modified Ampere circuital law is given here. So that is called Maxwell's Ampere's law or Ampere Maxwell law. Okay, so here we have the conventional current along with the displacement current. You can write IC also. So if you split this, so what you get, B dot dl, which is equal to mu naught. Mu naught means absolute permeability, that can be multiplied with IC, okay, plus mu naught into this term, mu naught epsilon naught d phi e by dt. So we have one more formula, that is C is equal to 1 divided by mu naught into epsilon naught under the root. So from this, what is mu naught into epsilon naught? 1 divided by c square. So that also you can substitute here and you will get the formula, that is B dot dl is equal to mu naught into IC plus 1 divided by c square into d phi e by dt. Okay, this is one formula. Like this, there are four Maxwell's equations. All are very important. So first one is Gauss law in electrostatics. Actually, you have studied this formula, that is phi is equal to Q by epsilon naught. That phi can also be written as what? Phi is given by E into A into cos theta. Correct? No? That integral form of that is given like this. E dot dA. E dot dA. So that E dot dA, integral E dot dA is Q by epsilon naught. That's why it is Gauss law in electricity. And then we have Gauss law in magnetism. So that is total magnetic flux over a closed loop is equal to 0. Any closed loop is equal to 0. So that is Gauss law in magnetism. And then we have Faraday's law. There we have E is equal to minus d phi b by dt. The rate of change of magnetic flux linked with a coil produces EMF in it. So that EMF is given by this formula. So that is line integral of electric field E dot dl. So how did we get, how can we relate electric field with the voltage or EMF? We have studied that V is equal to E into dV is equal to E into dr, or E is equal to dV by dr derivation we have done in equipotential surface. Now in that way we have written EMF as line integral of electric field. So then we have last one that just now we have studied. So these are main four Maxwell's equations. Just go through them. Then we have Maxwell's prediction of electromagnetic waves. So accelerated charges produces electromagnetic waves, and there is some theory about it. So just go through it. Here I'm going to give, let me consider second point also. Say electromagnetic waves are those waves in which there are sinusoidal waves of electric and magnetic fields. Because to write the formulae for these two, I need you to explain this. So electric field as well as magnetic fields will be there. They are vectors at right angles to each other, and they move perpendicular to their vibration in the same direction. Okay, so right angles to the direction of their propagation. So the diagram is given here. The red color one represents the electric field and the other one represents the magnetic field, and they are traveling along, you can consider x-axis. Let's consider electric field is vibrating along y-axis and magnetic field is vibrating along z-axis, and both of them traveling along x-axis. So in equation, how can we represent this? So electromagnetic waves contain both electric and magnetic fields. So here we have EY, means that is electric field vibrating along y-axis, oscillating along y-axis, and its peak value is given by E naught. E naught is a peak value, maximum value. So in the same way we have BZ, that is magnetic field along magnetic field vibrating along z-axis, and its peak value is B naught. But when it changes its What is that? The angle. So you may have to consider the change in the value of electric field as well as magnetic field because they are sinusoidal. So the theta is given by kx minus omega t. So where Ey and Bz are the electric and magnetic fields in those particular directions, and E naught B naught maximum values. K is called propagation constant. K is called propagation constant, that is given by, this is very important formula, K is equal to 2 pi by lambda. K is equal to 2 pi by lambda, where lambda is wavelength and omega is 2 pi f. This can also be given by 2 pi by t. 2 pi by t. Then we have the relation between the magnitude of electric and magnetic fields. So that is given by B naught is equal to E naught by C, right? E is equal to BC. So E naught by B naught is also called C, and C is equal to 1 divided by square root of mu naught into epsilon naught. Okay. Next, expression for speed of light in terms of absolute permittivity and absolute. Just a minute. So absolute permittivity and permeability. So that is C is equal to 3 into 10 to the power 8 meter per second. Next we have speed of electromagnetic wave in medium. So in a medium, if you consider it is nowhere be equivalent to C. So it will be, there will be some change in the speed of the light when it enters a different medium of different refractive index. So we have to consider this formula, that is V is equal to C by N, where N is refractive index, that is given by square root of mu r into epsilon r. You may have to consider that and substitute here, and C is also there. So if you substitute, you will get this. Let me consider here V is equal to C by N, where C is 1 divided by square root of mu naught into epsilon naught, and N is square root of mu r into epsilon r. So 1 divided by square root of mu r into mu naught and epsilon r into epsilon naught. So from that you'll get 1 divided by square root of mu into epsilon, because mu is equal to mu naught into mu r. Epsilon is equal to epsilon naught into epsilon r. That is one thing. Then we have characteristics. So electromagnetic waves are produced by isolated charges. This you can expect for 1 mark questions in the board level examinations. Then we have electromagnetic waves are transverse in nature. So next we have the oscillations of electric and magnetic fields are in the same phase. So the momentum and momentum carried by the electromagnetic waves is given by energy by C. So then we have electromagnetic waves do not require any material medium for the propagation. That is, electromagnetic waves are non-mechanical waves. Non-mechanical waves. Correct. Now, next we have density of electromagnetic waves. So that is given by electric field density is given by 1 divided by 2 epsilon naught E square, and magnetic field density is given by 1 divided by 2 mu naught B square, and when you add them, the total energy density of electric and magnetic fields is given by this formula, that is 1 by epsilon naught E RMS square plus 1 by 2 mu naught B RMS square. So here E RMS is given by E naught by root 2, and B RMS is given by B naught by root 2. So you can substitute that and you will get these equations. Okay. Next we have Poynting vector. So Poynting vector represents the direction in which electromagnetic wave is traveling. The direction of Poynting vector is the direction of electromagnetic wave propagation. So that is given by this formula, S is equal to 1 by mu naught E cross B. Okay. Then we have electromagnetic spectrum. So in that we have arranged the what is that? All the electromagnetic wave radiations in the decreased order of their wavelength. So initially we have the radio waves whose wavelength is too high, energy is too less, and frequency is too less. So in the decreasing order of their wavelength and increasing order of their energy and frequency. Here energy is too high, frequency is too high, wavelength is too less. So initially we have radio waves, then we have microwaves, then we have infrared radiation, then we have visible light, ultraviolet, X-rays, gamma rays, cosmic rays also there, but they are not considered in the electromagnetic spectrum because of their high energy. Um, and it is very difficult to find out the wavelength of those radiations. So this is about the list of formulae, but for board level and all, you may be asked to write the uses or applications of different kind of electromagnetic waves. You please practice it. So based on theory also, I'll make one more video. So we'll meet you in the next video. Till then, take care. Bye.